All right, October 3rd, we're finishing up with 6.3. We'll do 6.5 and 6.6. So here we go. Use the definition of common and natural logs to simplify. E raised to the ln of 1.17. It is just, and this is a property, guys, it is just 1.17. If you do this on your calculator, you can prove it out. You can take E raised to the ln of 1.17 and you get 1.17, right? So the red property, E raised to ln of x, is just x. And it also have the blue property as well. That's the reciprocal of the other. Well, I shouldn't say it's the inverse of it. Ln, a natural log will kill a next exponential E, and then an E will kill a natural log. They cancel each other. That's like multiplication and division of the same number, right? So, all right. So not a big deal. Just more properties and understanding than anything. But you could do it in your calculator to prove it. All right. Use the formula M equals log 10 of T to find the magnitude of an earthquake with a shock wave that measures 100,000 on a seismograph. Now, what you have to understand is, the magnitude is really Richter scale, right? So it's log base 10, and we don't even have to put the 10 there. Traditionally, it's this, okay? That's traditionally what you would see. Let me erase the 10. I over some I sub 0, because the intensity is really in terms of, guess what? It's measured in units of I sub 0s, okay? So they put this down here to cancel out the unit, is what they do. If you go back to traditional calculation Richter scale. So you're basically taking the log of 100,000, which should be 5, should it not? Yeah. So on a Richter scale, it's 5 on a Richter scale, right? Yeah, no, positively sure. Yeah. If they ever want you to do ten raised to the Richter scale would equal intensity, right? They won't ever ask you that, but just for grins and giggles, you know, you're sitting there home 2 years from now and there's an earthquake and you go, I wonder what the intensity of that was. You can pull out your notes and you can go 10 raised to that power, you know, to the Richter scale, and you go, all right. Oh, no. All right, so or you can just email me. I have useless information tied around my brain somewhere. So there. All right, any questions? It's a simple chug and plug. Okay. Yeah. All right, guys. We're done with 6.3. Ready? Woo-hoo. 6.5. Here we go. You picked those notes up the other night. I had those up there, 6.5 and both 6.6. Okay. Log properties, the product rule. If you have two things tied together by multiplication, then you can split them by an addition. Now, they say for when the base is greater than 0, right? Anybody know why they put that stipulation there? That's right. You can't have a negative base, right? Can't 0 or, right? You think about it exponential, right? It has to be greater than 0, and it can't be equal to 1. It has to be up in the power, right? Same thing. That's why they've put in that little b is greater than 0, because the base of the log is also the base of the exponential. So there. All right. So the quotient says if you have two things being divided, you can separate them by subtraction. There you go. Any questions? Power rule. Anytime you have the of right here, you can bring it out. Log base b of m, the of part. If it's raised to power, you can bring it out in front of the power. Or not in front of the power, in front of the log. Sorry. So the number in front of the log is really the power of the of part, right? There's a mathematical term for those, but I don't remember it. For what this part right here is, that little particular thing. Okay. So it just goes out to the front, and vice versa. If you need to move it back up, then it can go back up here, right? Okay. Power rule. So we've got product, quotient, and power. Those are all on the back of your formula sheet. Okay. Change of base. We've done that, right? We said n is the common base, right? It's the 10, correct? So I'm not sure why they put that, but anyway, the log of over the log of the base, right? So base always goes in the bottom, right? That portion log of that always goes in the bottom. All right. Any questions? Y'all good? Yeah, I figured so. Y'all know those like the anything, right? Mm-hmm. Yeah. Yeah. Mm-hmm. Sure. Yeah. You know what the cool thing about it? You can do the change of base with natural logs. You know that? Sure can. Because the natural log is nothing more than a log to a base of E, right? As long as you keep those bases of those logs the same, that's why they had the N up there. But we normally do it with the calculator anyway, right? If we're going to do a change base, we'll do it with, and it's a base 10, so we ain't got to worry about anything, right? So, there. Uh-oh. Sorry. All right. Now, let's go have some fun. Let's go nerd out. Expand that right there. Well, there's not but one property that I see. How many properties do you see? Just one? Which one is it, y'all? Huh? Yeah, but what property? Huh? Yeah, it's the power property, right? We're going to put that 4. So it'll be 4 times log of what? X, right? Yeah. So that's expanding it, right? Any questions? Okay. What about this? Well, we got it. A division, right? So we've got, what is this? So it'll be log of 1 minus log of what? B squared, right? And then what do I have to do? I have to take this out to the what? To the front? Can I, let's see. Is there any? Oh, guess what? Look on your property list and see if the log of 1 is 0. Yep, there you go. So this is really 0 minus 2 log of what? B, right? Because this becomes 0. Now, how do you check that? Well, if it's the log of a number, guys, you need a calculator. And it'll bring back up. You go, oh, that must be a property. Right? If you get a 0 and a 1, you take the log of something, it's probably a property. Okay. And then this simplifies down to just 2 log of B. Right? -2, that is.
So on the test, we would have to just not have
That's exactly right. 0 is nothing, right? So, okay. Any questions? No, there'll probably be, there's two properties. Log base B of B, right, with the base and the of are the same. So log of 10 would be 1, right? If it was common log, or you log base 5 of 5, they'll do that. They'll also do the 0 one, log of 1. And then that's about it. They're not going. They're just gonna mess with you on properties. All they're gonna do. Okay. All right. Now, what about this one? Let's see what you can do on this one. Okay. Give you. All right. So we're looking at log base 5 plus log, not base 5, log of 5 plus log of B. Right. It's a common log, so we ain't got to worry about a base because the base is 10. Any questions on those? You good? Yeah.
So anytime it,
If they're tied together by multiplication, you separate them with a log, and that plus log of the other, right?
if there's no base, it's always.
Yeah, yes, it's known or understood to be a common log, which would be a base of 10. I mean, I could turn around and do this, right? And it ain't gonna matter because it's understood. If no, a log with no base is understood to have a base of 10. So, all right, let's go have some fun. If we can expand them, guess what? We can combine them. Anybody know where you got to start? There's one rule of thumb that you have to make sure you do before you can start combining them. Now, you can see that it's subtraction. That means quotient, right? But there's one thing I got to do before I can start recombining them. I got to get my logs where there's nothing in front of them, right? I can't combine them until I have my logs free of what's in front, right? Because what's in front is really a power, right? So you got to be mindful of that. That's the little kicker nugget of knowledge you got to make sure you have. Yeah. Okay. All right. Y'all do this one. That's what I got. Note that I wrote it again. You know, I showed what I was going to do, and then I actually wrote it. And then it's easier to see how they come together. Okay? If you start shortcutting this, you're not going to feel comfortable and confident in your abilities. Okay? All right. Any questions on recombining? The homework on this should go pretty quick. All right. Jeez. Okay. We'll have a discussion about the answer on this one at the end. I'll give you, I don't know, a 30-second head start. Ma'am? Purple is probably where they're going to end up with in your homework. I doubt they'll let you stop at the red. They may. They may. But I very seriously doubt it. Anytime you have a fraction of a power, the denominator is the root, right? So if it was, if your denominator was a 2, that'd be a square root, right? These happen to be 5 and 3. So it's the fifth root of x and the third root of y. So it's probably going to be like this. But what I want you to get comfortable with, or at least can do, is take it from the purple to the red. I want you to be able to take it from the purple to the red. Because if you can take it back to there, you can go the rest of the way. Most people have problems going from the purple to the red. Okay? Oh, now come on. It's here. We'll give you this. Uh, that's the that's a B. I I was gonna make it an A, but I thought, okay, if I put B over A, then it's kind of backwards in the alphabet, and OCD comes out. So I don't want to do that. Okay. And sometimes you'll see it like you could also see it like this. These two are alternate. Either one's fine. Evaluating, I like to write when if I have to evaluate some numbers, because I like to take the root of it and then raise it to whatever power. Okay, that's just how my brain works. So there. But anyway, make sure you can do that. It'd be great if you could do that. Oh man, write the single expression below, or write the expression below as a single log. Okay, this is either your wheel's gonna fall off or you'll get successfully there. But if you can combine them, then guess what? You can expand them, right? So, all right, go. Yes, is the. I put a thing through it. Yeah, I put a thing through it. I yeah, yeah. That's been since ninth grade. I had this physical science teacher that made us do that to copy her notes. Yeah, I just so and it's just stuck. Yeah. There you go. You go. Why ain't the y the basically square root of y over z to the fifth, and then times that? Why is, well, let's think about it. How do you multiply fractions? Top to top, bottom to bottom, right? So that's why it's you work it. That's on the denominator. That's on numerators, right? That will mess with you if you're not straight on that. That's the hardest it gets. I killed the ones that were just, yeah, I'm like, these people are not math majors. Why? It's crazy. It's not going to do that. You need to understand how to condense and expand logs. You don't need to know all the, can you take one that has 10 variables in it with square roots and everything raised to powers and craziness? No, that's just mental anguish. All right, y'all good on that one? Kind of feeling like you get your feet underneath you on this concept? Yeah. Okay. Do $500,000, you'll be fine. Really? Okay. Okay. So the previous problem should give you some indicator on how this one's going to look, right? Correct? I'm just curious. Who can go straight to the final answer just by looking at it? Man. Okay. You've been doing too much math today. You done killed your brain already. Yeah. Okay. Go. I'll give you 30, 45-second head start. All right. So let me show you how my brain works, okay? I'm going to go ahead and just log of a to the fifth plus log of b to the fifth. That's an a. Minus log of what? C to the sixth, right? Is that too much of a stretch? Yay or nay? Last thing, take these out to the what? Front, right? There you go. Hey, all right. Hey, if you can do it in, I hate to say one step, but if you can, then you're seeing the properties. And that's really what you need. This task is really getting you to do, understanding the properties. So, all right. If you don't sweat it. It's, just do it. You ought to be able to do it in 2 steps, right? Things tied together, addition, and then minus the other one, right? Okay. Change the base. We already done change the base, have we not? On this? This is log of 21 over log of what? 2, right? Evaluate that in your calculators, please. Use calculator to approximate 4 decimal places. You might want to do this because you may see this again in a short period of time. If you've got a calculator that allow you to input the base into it, which is what the TI-36X Pro will do, they'll you hit that again, hit it again, now you can put it in. See that? Once you get to the log the first time, if you hit the button again, it'll go so you can put a base that's other than 10. So yours, if you hit the LN, the log button up top, hit it one time, it'll go LN, hit it second time, it'll go log, hit it a third time, and then you can put the base in the oven. What about the 33 multi-views? Most of y'all got those, right? Some sort. Doesn't have it? Okay. Yeah. If you got an 84 with a new program, I think it's under it's under math. So if you got an 84, it'll be under math. The very bottom, it'll say log base. It's A, I think, if you got the latest program on there. You got to load the latest. If you hit that, guess what? All that is somebody wrote a program so that it would do the change. You're taking the inputs. You're still doing the same thing that's on the screen. 84 has curves. 83 has squares. It's just, yeah. 83 is curves. and it has a little bit. The key sequence is the same, but it has just a little bit more. Um, may only have a couple of things different functionality wise with the programs. Yeah, I don't think it has this. I think 84 is where these pick up, right? Because you can't update the software anymore for 83. Yeah, it doesn't matter. You can't do it anymore. It's just they don't update it anymore. They don't support it anymore from a software standpoint. So all right, so what y'all get? I'm just curious. 4 decimal places. 4.2. 3923. There you go. 3923. There. Yeah. All right. Okay. Questions? All right. That's it on 6.5, guys. Nice and easy, right? Yeah. All right. So 6.6. Well, let's go here. Oh, there it is. All right. So these are the properties that you really use when you're doing logs and exponentials. Okay. So there's. I just wanted you to get a an understanding, and we've talked about this. This property says for exponentials, if the bases are the same, and this is Palmer's, okay? If the bases are the same, then you can take their exponents and set them equal to one another and solve it, right? But you got to get the bases the same. That's the key for an exponential. But if you can't get that, then we're going to show you what to do. And this is take a log. If you're solving a log, convert it back over into a what? Exponential. We saw that in 6.3, did we not? Convert it over in, and there was some of that we just had to take the base raised to some power, right? It's like log base 5 of x equals 1.3 or something like that. Some craziness. Okay. And there's also, let's see if they have this property. Yeah. So I told you exponentials and logs are inverses of one another, right? So yeah, if you could take the bases of an exponential and just if they're the same, you can set their exponents equal to. If you have a log with the same bases, then you can set their ofs, right? But that's if and only if the bases are the same, right? Now always check to see if your answer is correct because and make sure it's not an extraneous solution, right? Why? Anybody know why? It's the one thing you can't take the log of. That's exactly right. You might solve for something, okay, but plug it back in. Like you may say, take the log of 2x minus 19, right? Solve that, right? And then you solve for x, and you end up having one answer, and you plug it back in. It gives you a negative number, right? You can't do that, all right? So just, I don't think we're gonna go that deep, but just kind of be familiar with that. Now, one other thing you need to make sure you understand. If you can't rewrite exponentials to be the same base, then you'll take the log of both sides. Okay? And we'll show you how to do that. That works 100% of the time. Okay? Getting the bases to be the same only works when you can get the bases to be the same, right? Rewriting powers, like, okay? All right. So here we go. Hey, look at this one. Look at those. That's exponential, right? Look at those bases. What do you know about them bases? It's all about the, no, no. Wait. Show me the money now, right? Yes, you show me the money. No, it's all about the money. Hold on. All right. So, huh? No, no. Nope. All right, so the bases of the exponentials are the same, right, guys? So we can sit here and do this. 3x equals 2x minus what? 4, right? And then you can just solve it, and you get x equals -4. And x is -4 is the answer. Questions? Okay with that? Okay. Huh? All day. Okay. Well, let's step it up. What about that one up there? Yeah, you can. You can. You use the properties of exponents. Lord have mercy. Um, you you got to think about powers of 2s, 3s, and 4s, as well as 5s. 2's up to about a power of 6. 3's up to a power of 4, 3 to 4. 4's up to a power of 3, and then 5's up to a power of 3. If you're familiar with those, then you can rewrite bases pretty good. Okay, I can rewrite this if my memory serves me right. Yeah, I can rewrite this 2 ways and still get the same answer. Just depends on what base you want to go to. Okay. So we got 4 and we got 64, right? Okay. You want to try 15 seconds, 20, 30 seconds? No, you just want me to show you? Lord have mercy. She just knows she's not going to get it right. Oh, yeah, little faith. All right. You gotta have the faith of a mustard seed, right? Small. All right. So I can rewrite 64 as a power of 4, right? I could change these over and rewrite them as bases of 2. I don't want to do that. Okay. And I'd still get the same answer. It'd just be a lot more work. So I look at something and I go, okay, can I take that base and rewrite the other one in terms of that, in terms of power? And I can write 64 as 4 cubed, right? That's 64. Now, that's also being raised to the x plus 1, right? Now, what you have to make sure you understand is you brought back in those properties of exponents, and it's the power to a power. When you have something that's raised to a power, raised to another power, then you multiply these. So these are really I normally do that. And the reason why I don't distribute it through at this process, what happened? Huh? Where? Oh, no, no, no. The what now? Okay. All right. So I rewrite 64 as 4 cubed, right? So that took care of 64, but that 64 is also being raised to x plus 1. So you're going to multiply these, right? So that's why I wrote this 4 raised to 3 times x plus 1. I don't want to go ahead and, some of you might, and that's fine. I don't, because there's too much going on. I'd rather distribute when I'm sitting here. Now I've got bases that are the same. Now I can do this. Uh-oh. Now I can distribute. And solve it. X is -4, right? Now, how do you know if that X is -4 is correct? You can plug it back in. Left side should equal the, after you get done raising it to the power, right? Whatever it said to go to, right? Okay. Yeah, back into the original. Yeah, you always go back into the original because you have no copying errors there. And as long as it's written down, you'll have any copy error. I mean, if you rewrite it, then you have a chance for copying error. So, all right, any questions there? Mm-hmm.
Like when you go to put it back in, like if I put -4 back into
So it'd be -4 plus 1, which is what?
-3.
-3. So 64 raised to -3. We know that would be a fraction, not a decimal, because the negative exponent. So 2 times -4 is -8. Minus 1 is no. -8 minus 1 is -9, right? So 4 raised to -9 should be the same as 64 raised to the -4, right? Or 5. What is it? 3. Sorry. I can't do math tonight. Sorry. Yeah. Oh, well. All right. Y'all good? I've got the same base, right? Y'all agree I got the same base? But what do I have to do this part right here? I can't get rid of it. I've got to, no. Yeah. I've got to rewrite it as a fraction of a power, right? Because I need to keep that base 7 there, right? So here's the 2, right? You remember this? We said what? X A over B equals that, right? You remember that? Yeah? Yeah, it's just like yesterday. It's all coming back, right? Okay. So now I got 7s, right? The bases are there. So now it's 3x equals 1/2, right? So I will turn around and divide both sides by 3. So x equals here, there. So that's B, and there's A, right? And the A is 1, right? Here's a 1, and here's a 2, right? 7, right? And so I've taken these and putting this on the bottom, that's on top, right? Yeah. So that's 1/6, correct? I highly recommend what I just done right here. Unless you just put it in calculator. I mean, calculator do, I don't know, 0.5 divided by 3. Yeah, I'd do it all day long. Yeah. Well, but if you hit math and then hit enter, it'll take it back into a fraction. And there's also little keystroke buttons. Like if you hit the green, I think green that one, or green y equals. It's the green y equals. Right there, look, the green, and then the y equals button. It'll pop up a menu. It's pretty cool. You can do fractions. It's shortcuts. Yeah. Anyway. Okay. Y'all ready?
Please convert fractions or decimal to a
Yep.
fraction.
The button right above the enter is a catch the wave type thing. So you could type 1 divided by 2. Enter. No, you have to hit enter.
Yeah.
You have to hit enter. Okay. Now, what did he give you guys?
0.5.
Okay, now hit the button above it. If you hit
I
the,
did.
and it'll give you back as a fraction. So that, and you hit the button again, and it'll go back to a decimal. So that's how you do that. Yeah. You turn it on.
No, I know. Cool stuff like that.
Oh no.
I don't know the last time I've used a calculator, so.
Yeah, mine was about 2 hours ago.
Well, I mean, since
All right. Okay. So x equals 1, 6, right? All right. Oh, man. 10 raised to x equals 4. There's no way I can get 10 and 14 to be the same base, can I? Can you? Not even with prayer can you get it to be. So, yeah, we're okay. We're going to take the log of both sides. So you just go log of 10x equals log of, guess what? 14. Now, you remember those properties that we just got done doing? This is really cool. You take that x out, so it's x times the log of 10 equals log of 14, right? Now, this is awesome. I don't care who you are. This is great. See that log and that x are tied together by multiplication. So if I want to get rid of them, I just divide both sides by the log of 10. And that will give me x, which is, make sure you close parentheses when you type in log, right? It is. It is wonderful. Yeah, man. It's great. I got 1.1461, right? Yeah? You know why I went to 4? Because my calculator went to 4. You can change it. Hit mode. And then second mode to quit. Um, anyway. Yeah, it's crazy. It's a lot of capability right there in that calculator. Okay. That's how you do it. That's how you solve it. And the really cool thing about this, guys, on those previous problems, guess what we could have done instead of making the bases be the same? We could have took the log of both sides, brought the power out, which would have the variable in it, right? And rock and roll from there, right? Okay. Questions? That's what I wanted to make sure you were exposed to. Because there's some of y'all that leave and take 11, 13, right? So I want to make sure that you're equipped enough to do that. I don't know. Not me. No, no, no. No way, no how. I've done my time. But I will tell you this. Trig is probably one of the... Yeah, it is. It makes doing the math and solving stuff easier.
Because you already learned this stuff before.
I know. But it's pretty cool. And you get in laws of cosines, law of sines. Uh-huh. Yeah, that time thing normally plays a big factor when you come back. Yeah, they make you go back and take stuff. Yeah, there's something about money. So, all right. Okay, so solve the equation by rewriting the exponential expression using the indicated logs, and then use the calculator to approximate the variable to 3 decimal places. Okay, so, all right, man, this right here I'm going to tell you. It's crazy. So we're going to do this one, okay? So we're going to take the log of both sides, right? Now, any questions about what I just done? Okay, now what about this? What if I took this out to the front, and that would be 3x minus 2 times log of 5 equals log of, guess what? 36, right? All right, anybody know what I'm about to do? What? Well, I could. I could. You're right. There's 2 paths here that I could take. You could do that. You should get the same answer. because you're not breaking any. All right. Yeah, I took that to the front, right? Because it's power, right? The power property of a log. Now, this is 3x minus 2 times log, right? So in theory, we should be able to take and divide both sides by log of 5, right? And that would be 3x minus 2 equals log of 36 over log of 5, right? And then I got to turn around and do what? Add 2 and divide by what? 3. Now, it doesn't matter. Or you could distribute the log through, and that'd be 3x times log of 5 minus 2 times the log of 5, right? What you want to do?
Divide by log of 5.
See what I created? Only in 8 weeks, see? Jeez. They said it couldn't be done. Brainwashed y'all. Little nerds y'all are. So that was. Ha ha ha. It's a pocket protector. What do you mean you don't have one? I don't wear shirts with pockets in them. Huh? Nerd pride. One day. I know. All right. So, all right. So, okay, we'll divide by log 5, right? So that leaves me 3x minus 2 equals log of 36 divided by log of 5. Uh-oh. I can't write that down there. That's bad. Now, I've got to turn around and I've got to add 2 to that. And then I also have to turn around and divide it by what? The whole thing by what? 3. Do y'all see what I just done there? So that's what my x is going to be. So I've done this in I've done it in one step, but 2 things. I added 2 and divided by 3, right? So I add the 2, boom, and then everything's divided by 3. So I'm going to tell you something. In your calculator, this is how I would do it. Am I on? Yeah. We're live. Okay. So I would take log of 36 divided by log of 5. Enter. Then I would add 2, hit enter. And then I would divide by 3. So, ladies and gentlemen, give me the answer to how many decimal places? 3. 1.4 what? 1.409. It's the cleaning thing. All right. 1.49. Y'all agree? Yeah. Did you put the whole thing in and get it right?
Yeah.
There you go. Buy a lottery ticket. I understand that the thing is the jackpot's up, right? No? I don't think nobody hit it. Huh? I just give a couple of dollars away. If you think of it like that. Can't win, let's play, right? Yeah, it is. So. All right. Any questions on that? If you want to nerd out, you could distribute the log 5 and then add 2 log 5 over, and then divide everything by 5, right? I mean 3, and you'll be okay. I mean, if you really want to. Proves that you can get the same answer, right? This is why I love math. What?
You said the way you would enter it in your.
Oh, I'd do the purple first. Log 36 over log 5. Hit enter. Then I'd add 2. Hit enter. And then I would divide by 3. I would take each operation and chunk it. I would take control of the order of operations. That's what I would do. Okay. Snap. What about this one? Anybody? Well, let's first off, let's kind of look at this thing. I would divide both sides by what? I like that better, right? So if I divide it by 20, that's I think last time I checked, that's 5, right? Y'all agree? All right, good. Now, how do you get rid of an e? You take the natural log of it. What you do to one side, you must do to the what? Sweet. So I'm going to take the natural log of 5 equals natural log of e to the 4t. We know that these two jokers cancel out, so it's natural log of 5 equals 4t, right? Then just divide both sides by what? So t equals natural log of 5 divided by what? 4. That's a property, folks. And the one thing I don't like about your formula sheet is they don't have the properties of E. I mean, not E's, natural logs on there. But I will tell you this. You can replace all the properties with logs with the word ln, and everything should work out good. All right. Any questions on this one? How many more we got? Man, I got to make this last 8:50. Not really. Okay. What you want to do? No, I've given you enough tools in tool belt to go. The what now? You want to take it out, move it to the other side? I guess you could. What if I done this? Ah, watch what I'm about to do. Well, okay. Okay. Let me back up, punt. That's going to be an easier route. Because watch what I'm about to do. Because I'd have powers. I'd have to do force and Q, and I don't want to do that. And then I should be able to do this, right? Yeah? If I factor something out, if I distribute it back through, I ain't.
Oh, okay, yeah, threw me off when you read that now. That's just extra steps, though.
I know. But you got to see why. Okay, could you take 4e to 2t minus 3 and get 1e to the 2t? You most certainly can. But you're not going to see that unless I do what? If I just done that, you'd be like, oh, okay. How you know how to do that? Well, here, this is why. Do you see how I proved it? I'm left with two numbers, right? If I took an e to 2t out, that's 4 minus 3, which is what? Just 1, right? So now you know why you can do that. So if an e raised the same thing with a, that's a power, really, then you're just, well, it acts, really acting like a coefficient, right? So that's really broke down to this, right? Which we can turn around and now do, and these cancel. And I'm going to go up here so that we don't have to rewrite all the way over. So t should be the natural log of 2 divided by 2. And no, you can't say 2 divided by 2 is 1. You can't do that. Why can you not do that? No. It's a natural log of 2, not just 2, right? Okay. So what does it give me? 0.3466. Okay. Y'all good? Sweet. I'll look back through 6.6 just to make sure that I have culled all the craziness out. I have, but I just will make sure that I'll go back through. I'll look at it again. So, but it gives you opportunity to practice on those. Okay. All right, guys, here we go. Use the definition of a logarithm to solve the equation. Okay. Huh? Well, yeah. You divide both sides by 5, right? Because that's 5 times it, right? So that gives me log base 2 of x is equal to what? 2. That's how do you solve a log? Change it into a what? Exponential. Wait, my brain's jumping ahead of my writing. X is 4. You okay with that? The hardest thing to do is once you figure out what the first step is. Once you get that first step, then the ball's rolling, you're good. Because when you get from the black to the blue over here, you go, okay, well, I can do, it's just a log. Remember, I can't take log of both sides because it's already log, right? So how do you solve a log? You change back into an exponential equation. Okay. Huh?
Yeah, the next one.
Really?
Yeah, it's a solve the equation for x.
See? Solve it for x. Huh? Yeah, solve for x. All real numbers. Yeah. Yeah. Thank you. Really? Oh. This one's not as hard. Guys, how do you get rid of natural logs? Now listen. What you do to one side, you do to the other. In math, you're creating an equivalent equation, right? So I don't like them natural logs, so I'm going to kill them. Left with x squared equals 2x plus what? Ladies and gentlemen, what is that joker right there? That there be a quadratic. Yep. It's a power of 1. Oh, well, here's what I'm about to do. Why am I going to do that? Well, in order to solve a quadratic, it must be set equal to 0. Look at your highest power on your x. It's a 2. It's a quadratic, guys. So, yeah, they threw that in there just for grins and giggles. What multiplies to give you negative 15, but adds together to give you a negative 2. Ladies and gentlemen, there'll be a 3 and a 5, and the negative would go on the 5. So that's x minus 5 and x plus 3. If you got a TI-36X Pro, you just type that joker in right there and hit solve, and it'll do it for you.
Why again does the natural logs cancel out?
Because I'm raising both, doing E. If I had E's, I'd take the natural log both sides, right, to cancel the E. But if I got natural logs, they'd be the power of E. If I raise them to the power of E, then I'm good. You know that very first problem we had E raised to ln of 2, and it's equal to 2 because E and ln cancel out, right? Yeah, it's this principle. It's that. That's the property. Yeah. So, all right. So that's x equal to 5 and x equals to what? Negative 3. All right. All right, guys. I would. I'd check that, but as long as well, 2 times negative 3 is negative 6, but 15 is bigger than anything that I'd get that's negative, right, from these two answers. So, yeah. But you could check it, and you need to check it. You just as sure as I say they won't give you a problem that's going to have an extraneous solution for the quadratic because they're algorithmically generated. It shouldn't, because they're hard coding 2 answers on this particular problem. Now they'll give you one that's just a simple one. Oh my, that's it? You got to be kidding me.